What would happen if a star exploded nearby? Look at these pictures. Simply put, they are stunning. The longer you watch them, the more you pick up on details and appreciate the appearance of a supernova. Yes, the star death that you are currently viewing has already occurred. All stars eventually exhaust their supply of hydrogen gas and perish. How much matter a star holds greatly influences how it dies. Red giants are the result of the expansion of stars of our sun's mass. High-mass stars, on the other hand, develop into red supergiants. These supergiants are responsible for the supernovae. They explode in a massive explosion known as a supernova, which is colorful and wonderful to observe from Earth. But you would probably perish if you were in the vicinity of a supernova. Fair enough, I suppose, as dying huge stars can sometimes lead to the formation of new stars. Though you pass away, someone else could be born. However, the goal of this movie is to determine if there is a minimal distance that may keep us safe from a star that is ready to go supernova. A large star's stunning explosion is known as a supernova. There isn't enough mass in our sun to cause a stellar explosion. However, it seems unlikely that the Earth would be completely destroyed if it ever went supernova. Instead, the ensuing shock wave would completely burn up the Earth's sun-facing side. In general, sleeping on the night side of the Earth would be preferable. However, it doesn't end here. Everyone would be dealing with significant issues. Consider the average surface temperature of our sun, which is roughly 5,778 Kelvin. As hot as heck. To individuals on Earth, this temperature would feel like Antarctica. The planet would become nearly 15 times hotter than the sun's average surface temperature, according to scientific estimates. You would essentially be roasted. Additionally, material from the star itself is ejected at great speeds during a supernova explosion, and this material comes from the star itself. Thus, abrupt mass loss is a feature of this process. It's possible that our planet will stray into outer space due to the abrupt drop in the mass of the sun. Without a doubt, we wouldn't be circling our star in the same direction or at the same distance. It is obvious that the sun's distance, which is 8 light minutes distant, isn't safe at all in the event of a supernova explosion. Thankfully, it won't. However, stars outside of our solar system will. How close is it that it's safe? NASA estimates that for a supernova to cause harm to Earth, it would need to be 50 light years away. This is a considerable distance, but why 50 light years rather than, say, 30? Watch what happens if the supernova explodes at such a great distance, still not far enough for us to be safe. A supernova explosion within 30 light years of Earth would have a significant impact on the planet, possibly causing mass extinctions. Supernovae are so energetic that they emit X-rays and gamma rays, which would cause this to occur. The ozone layer, which shields us from UV rays from the sun, might be destroyed by these potent pollutants. Earthly life may develop mutations as a result of these radiations. A close supernova's radiation may also have the potential to alter our climate. However, it doesn't end here. There would be more immediate impacts. For instance, reef populations and phytoplankton would both suffer. The ocean food chain would be significantly disrupted in such a situation, which would result in the mass extinction of many species. The good news is that no stars 50 light years from Earth are on the verge of going supernova. In the known history of humanity, no supernova has ever been known to explode within 50 light years of Earth. Supernova 1987A, which occurred in 1987, was the most recent supernova to be seen with the naked eye. However, it took place roughly 168,000 light-years distant at a safe distance. From space, Hubble captured the scene as follows. Hubble's Wide Field and Planetary Camera 2 captured this picture in 1995. It depicts the Large Magellanic Cloud's orange-red rings surrounding supernova 1987A. The heart of the inner ring is made up of the incandescent remains of the supernova explosion that took place in February 1987. Before that, Johannes Kepler recorded the last supernova that could be seen with the naked eye in 1604, which was 418 years ago. Even though it went off 20,000 light years from Earth, it was brighter than any star in the night sky. It could even be seen in the daylight. As far as we know, it had no worldly consequences. How much each of these pathways adds to the overall number of IA supernovae we observe in the cosmos is still a subject of debate in the scientific community. However, we made an effort to learn more about Kepler's supernova. Through chemical and kinetic examinations of the gas and neighboring stars, we attempted to reconstruct the characteristics of the stellar system that caused the explosion. It was determined by scientists that it was the outcome of a merger between two white dwarfs. Amazing. We have therefore ensured that no supernova will explode too far from the Earth, allowing us to continue having beautiful dreams for the time being. We also mentioned how unlikely it is for you to see a supernova in your lifetime. Is there a possibility that our generation will get to see one of them? A galaxy the size of the Milky Way is thought to produce supernovae around twice every century. This indicates that a fraction of these occurrences may have been hidden from Earth by interstellar dust because it is significantly greater than the actual observed rate. The next similar event will almost probably be identified due to the deployment of new devices that can observe across a broad range of the electromagnetic spectrum and neutrino detectors. Nobody really knows if there are any deadly supernovae. According to one estimate, a potentially hazardous supernova explosion could occur close to Earth once every 15 million years. Another claims that on average, every 240 million years, a supernova explosion takes place near 33 light years of Earth. You can see that we truly don't know. It's something you couldn't have predicted. If you like this video, subscribe to the channel and turn on the notification bell to make sure you don't miss any of our future uploads. Let me tell you about a few stars that are genuine supernova candidates because we are talking about them here. You must first be aware that there are two different categories of supernovas. With so-called Type 2 supernovae, there is the traditional explosion. A very large star with at least 8 solar masses that is nearing the conclusion of its active existence serves as its progenitor. Only spiral galaxies exhibit them, and they are frequently found close to the arms. When material from the star's outer layers enters, a supernova detonation takes place. Then, after the core has finished collapsing, this material bounces off of it, providing the gases falling inward with an abruptly hard surface. Although we still don't fully understand how Type 1 supernovae work, they have a distinct explosive process than Type 2 supernovae. On the basis of their spectra, Type 1 supernovae can be split into 3 subgroups, IA, IB, and IC. It is believed that Type Ia supernovae develop in binary systems with a white dwarf and a moderately massive star, with material streaming to the white dwarf from its larger companion. Ik Pegasi is a binary system located roughly 150 light years from our Sun. It is home to the closest candidate for a supernova progenitor. Ik Pegasi A, the system's primary star, is a typical main sequence star, much like the Sun. The other star, Ik Pegasi B, may be a Type 1 supernova. It is a large white dwarf star. Since white dwarfs are so tiny and dense, Ik Pegasi B orbits Ik Pegasi A closer than Mercury does to the Sun. So how do we anticipate this explosion to occur? It is anticipated that the white dwarf will expand to a radius where it can accrete stuff from the red giant star A's extended gaseous envelope. The B star could disintegrate when it becomes large enough. The show will begin with this, and we'll be glad to see it through our telescope. Betelgeuse, one of the brightest stars in our sky and a member of the well-known constellation Orion, is yet another star that is brought up whenever the topic of supernovas is discussed. Since Betelgeuse is a supergiant star, its inherent brilliance is exceptionally high. One of the most well-known stars in the sky is Betelgeuse because it will eventually explode. A supernova is also likely to occur soon if a red supergiant like Betelgeuse suddenly dims and changes to a deeper red color, according to theory. The most intriguing part is that we watched Betelgeuse as it unexpectedly darkened, even though it is unlikely to erupt in our lifetimes. This increased the likelihood that the star was going to blow up. The last supernova in the Milky Way that could be seen from Earth was in 1604, and Betelgeuse is so close to our planet that its explosion would be brilliant enough to be visible during the daytime for weeks. This event would offer a spectacle unlike anything Earthlings have seen in generations. Later, astronomers discovered that the dimming was probably brought on by more commonplace factors, such as a blob of exceptionally cold materials developing on the star's surface, a cloud of dust blocking the star's view, or perhaps a black hole. We weren't seeing the sudden explosion of a star, that much is certain. But the time will come when Betelgeuse explodes. It will exhaust all of its fuel, fall apart under its own weight, and then explode in a stunning Type 2 supernova. When this occurs, Betelgeuse will become extremely brilliant for a few weeks or months, maybe reaching full moon brightness and becoming visible in the daytime. It won't impact earthly life in any manner because it is 430 light years away from our sun. Here's where the video ends. Thank you for viewing. What are your thoughts on supernovae? Tell us in the comments section below.